Okay, we want to start by just looking at a segment of the number line. Let's be real specific. We want the segment that runs. We're a piece of chalk in the universe, but that's kind of universal, isn't it? Okay. Let's see if we can write with this piece of chalk. There we go. Okay. Now this is what we're going to call the unit interval. It goes from 0 to 1. Now, on this interval, where are we going to find 1/2? Now you really want to stop and think about these things. I pause the video, whatever, before I answer them. When I pose a question, you want to think about the answer. You probably want to have a pencil and paper in front of you. You kind of write down what you see on the board a lot of times. Not always, but we've got this interval, 0 to 1. Okay, where's 1/2? Well, 1/2 is going to be halfway between 0 and 1. I think everybody knows that, so everybody probably could have answered that very quickly, and hopefully you actually did. So let's just say I got it right, and this is halfway. Let's see how I did. There's half. It's a little too far this way, but that's close enough. Okay, so there's 1/2. Now, if I cut the interval from 0 to 1/2 in half, then this point along the line, okay? So you should answer that yourself, and hopefully you answer that that's 1/4. Half of a half is 1/4. So I can actually write that statement. Okay, this means, of course, 1/4 of the interval from 0 to 1 would be the interval that you'd need 4 of to make the original interval. So we need 4 of these 1/4 to make an interval of 1. And you want to think about the numbers like this. Numbers are not just something you plug into calculators and do calculations with. They have meanings, and we want to really focus on meanings. Okay, so now we cut the interval from 0 to 1/4 in half. What do we get? Well, again, you should answer that. Half of a fourth. Well, how many of these does it take to make up the whole interval from 0 to 1? We need 2 of them to make up 1/4. We'll need another 2 to make up the 1/4 we have between here and here, and another 2 for this interval, and another 2 here, because we need 1, 2, 3, 4 of the 1/4 intervals to make up 1. We need 2 of these to make up each 1/4. So then we need 8 of these intervals here to make up 1. So that's 1/8. And we could continue to subdivide. So, how many more divisions can we make? If we divide this interval here in half, be about there. Okay. And we could divide that interval in half. And we could divide that interval in half. If I try to go much further, the chalk line is going to blend with this chalk line. But what do you think are the coordinates at this point and this point? Okay, you should think that through, but I'll just tell you, I'm not going to write it down. It's 1/16 and 1/32. It takes 16 of these to make this interval, because it takes 2 to make, okay. First mark I made, the mark halfway between 0 and 1/8, takes 2 of those to make 1/8, and it takes 8 of the 1/8 to make 1. Okay, so there we have 2 times 8, 16. And if we cut that interval in half, well, then we're going to need 2 of those little intervals to make every one of the 16. It's going to be 32. Okay, now for the initial graphing assignments you're going to have in this course, you're going to need to go down as far as maybe 1/8. Certainly as far as 1/4, maybe as far as 1/8. And we'll see how that's going to work out. Okay. Now, if I take the interval from 0 to 2, I can write an interval of the same length here. But this interval is on a different scale than this. This is the interval from 0 to 2. If I cut this interval in half, well, what's that? Well, pretty clearly, if that's halfway between 0 and 2, looks like it's fairly close. That's going to be 1. Half of that is going to be a half. Half of that is going to be a fourth. And half of that's going to be an eighth, and so forth. Okay. Now again, this interval goes from 0 to 2. This interval only goes from 0 to 1. They have the same length. That just means that this line is scaled differently than this line. We could scale another interval. We could scale the interval from 0 to, let's say, 1/8. If we cut that in half, what do we have? If we cut that in half, what do we have? Cut that in half. Cut that in half. Okay. So obviously, this is 1/8, meaning it takes 8 of these to make 1. Means 1 would be out there somewhere, be quite a bit further than the 1/8. But we would have then 1/16, because if this interval, if we require 8 of these intervals to make 1, we require 16 of these, because it takes 2 of these to make each one of these. And similarly, cut that 1/16 in half, take 16 of these to make 1, it's going to take 32. 2 times 16, 32. And then we would have here 1/64, and you can figure out what this one would be. Okay. Now, our intervals don't have to be horizontal. You can have an interval here. And we could declare that this interval goes from 0 to 4. So if we divide this in half, we're going to have 2. We divide this in half, we're going to have 1. We divide this in half, we're going to have 1/2. Divide this in half. Well, I don't have room to label it over here, so I'll do this as 1/4. And we can divide that further. There's 1/8, there's 1/16, 1/32. So this is how we scale graphs at the beginning of this course. Now we're going to see where we can go with this. Okay, now let's ask another question. Where on this scale is 1/10? Well, kind of expect 1/10 to be, it's a little less than 1/8, because 1/10, you need 10 of these to make 1. You only need 8 of the 1/8 to make 1. Now let's go ahead and put 1/10 on the scale of this graph. Okay, well, let's blue chalk indicate where 1/10 is. Now 1/10 is probably closer to 1/8 than it is to 1/16. Okay. And you might guess where that would be. I'm just going to ballpark it. If this is 1/8, I'm going to say, okay, it would be reasonable to put 1/10 here. So if this is 1/10, I put a question mark on that. Maybe it's close, maybe it's not. It's probably close. Okay, there's 1/10. Okay. Next question. Where is 1/100th? Well, We go down to 1/64 here. Okay. If we went one more notch, this would be 1/128, wouldn't it? So let's go ahead and just kind of write that in. This is 1/128. Hard to write the 8 down here. So 1/100 is a little more than 1/128 because, of course, you only need 100 of these to make one. You need 128 of these to make one. So between 1/64 and 1/128, we're going to find 1/100th. It's going to be somewhat closer to 128 than it is to 1/64. We won't worry about exactly how much closer. We're just trying to indicate this on a graph. I'm going to say maybe it's here. Okay. So that might be 1/100th. Now we could continue subdividing. I could get 1/256th here and a 512th here. I could even get 1,028th in there, except that the chalk line would be kind of merging with this. So 1/1000th, just a good measure. Where would that be? Well, it's actually got to be 10 times closer to 0 than 1/100th. And you should understand that. Okay, somewhere in really close to 0. Well, if we want to put 1/10 on this graph, where's that going to be? 1/4 is here. 1/8 is here. So 1/10 might be a little less than 1/8. And 1/100th would be hopeless, and so would 1/1000th certainly. One 100th is hopeless because it's way too close to 0. One over 1,000 is really hopeless. And you could go on with hopelessness. Okay, as the number gets smaller and smaller, it's less and less possible to represent it on the graph because it's too close to 0, and the chalk line does have some thickness. Okay. Of course, we could put 1/10 on this graph, be about here. We put 1/10 on this graph, it would be about here. We might even be able to squeeze 100th in. So again, we're going to see how this relates to the graphs of some of the basic functions that we study in pre-calculus. Okay, now let's talk about the meaning of 2 squared. I hope everybody knows 2 squared is 2 times 2. Square any number, you multiply it by itself. I hope. I've had pre-calculus, people come into pre-calculus courses not knowing that. So if you don't know that, well, now you do. Make sure you do. Okay, we have 2 squared. I think everybody pretty much knows. How can we represent 2 squared? Well, it's not punch button, okay? And it's not 2 times 2, counting your fingers, or 2 times 2, memorize it. 2 times 2 is 4, which everybody knows. To represent it and understand what 2 squared means, very helpful. Take a square and label the square from 0 to 2 on the horizontal direction and 0 to 2 in the vertical direction. So that now we kind of have it on a set of coordinate axes, although we don't really need coordinate axes to understand what's going on here. And now from 0 to 2, we divide that interval in half, we get 1 in the middle. And the main thing is we get a line here that divides the square in half. Then we do the same thing here. We divide it in half again. So that this square is 1 by 1. Well, that's going to be a unit. Okay, so this has an area of 1. And what I should have done, I'll just put a purple circle around this. Might be hard to read that word area, but we're just indicating the area is 1. Area is 1, area is 1, area is 1, and well, there is 4. So 2 squared is 4. Another way we can understand 2 squared. Take an interval here. Put 0 here. And 2 here. And then 2 of these intervals would be 2 squared. So we take the length of this interval and add it here. Of course, that gets us out to 4. Two twos is 4. I just put this in context. Let's say we want to do 3 squared. I've got to leave myself a little extra room there. Let's just put 3 about here. Here's 0. 3 squared. Just 3 times 3. So we have this. And we have another one of these. And another one of these. So where does that put us? Well, we add 3, we get 6. We add 3, we get 9. Now we know 3 times 3 is 9, but we want to have this picture, 3 times 3, and maybe this picture of 3 times 3. I can label this picture. But here we have 1, 1, 1, 1, 1, 1, and 1, 1. 3 squared is 9, just following the pattern that we had for 2 squared. So there's a geometric picture and a straight line picture of 2 squared and 3 squared. And you can think about what 4 squared would look like, 5 squared, 6 squared, and so forth. And you really should do that. Okay. What about 2 cubed? Well, we can draw that as a picture. And we can start the same way we did up here, but now we've got to double that. Okay, that means we've got to do 2 squared, and then we've got to do 2 of those. So we sketch this picture. And we can see this as a stack of dice or something. And we see that the total volume, okay, well, we can't really see the cubes inside here, and I don't want to draw them, but should be able to understand. And I'll take a chance here. I'll say the total volume is 8 unit cubes. By unit cube, I mean a 1 by 1 by 1 cube. So like this is one here, and it's one here, and it's one here. Okay. So this cube here. Has a volume of 1. So 2 cubed is 8. Now, if we wanted to draw a picture on a line here, where the picture starts to get a little bit interesting, we put 0 here and 2 here. I want to leave myself some room. Okay. This is 0 and this is 2. Then 2 of those would make 4. And that's, of course, 2 squared. And then 2 of these we're just out here. It'd be 4 and 4, which is 8. And then if we want multiply by another cube to get 2 to the 4th power, it'd have to be this, and this would be out here, it'd be 16. Now here we're starting to get into a little bit of interesting mathematics. And I'm just realizing that my camera needs to move a little bit to get the entire picture over here, and hopefully understood what I was saying about the 9. I think that was not there. Pretty much everything else was. Okay, so saying that we're getting into a little bit of interesting mathematics, and seeing the pattern of how these numbers occur. If I wanted to put 16, it would be out here, then 32 would be twice that far. It wouldn't take us long, probably within 16 is about a foot. That would be 1, 2, 3, 4 steps. If we get 16, in 10 more steps, we'll have over 1,000 feet. And in 10 more steps, we'll have over 1 million feet, over 200 miles. It doesn't take many steps for these numbers to build up quickly. And that's something we really need to understand. In order to understand the functions, which are this topic of our course. I think I have enough. Now I want to do 1/2 squared. There are ways to picture that. 1/2 squared but we imagine a 1 unit cube. We can do half of that cube by cutting it, let's say, along this line. And if we slice it along this line, of course, we get. And then if we I'm sorry, I got ahead of myself. I wrote square and I was cubing. Okay, so 1/2 squared. We can take a unit square, 0 to 1 here, 0 to 1 here. And we can cut it in half this way. And now we've got 2 pieces. But 1/2 squared means 1/2, 1/2. So we cut it this way. And we get 4 pieces. So we do we have it once. And we have it again. So we have it this way, and then we have it this way, and we get 4 pieces. And each of the 4 pieces is 1/4 of the original square. So one-half squared equals 1/4. That's why 1/2 squared equals 1/4. Not because of some rules you learned about fractions, not because your calculator says so, but because that's what it means to take half of a half. And if we want 1/2 cubed, I'm not going to go through the complete explanation. But we can take a cube, we can cut it in half, kind of the way I started before. I'm going to in a different direction. And now we've got 2 pieces. We cut it in half in another direction. And now we've got 4 pieces. Each piece is long this way, and it's square this way. And then we cut it a 3rd time. And now we've got 8 pieces. Have it 3 times in a row, we get 8 pieces. So 1/2 done 3 times, 1/2 to the 3rd power is 1/8. And of course, we could also look at it this way. Got the interval from 0 to 1. We cut it in half. We cut it in half again. This is the result of cutting something in half twice. We take the same interval, cut it in half, cut that in half, cut that in half. We have 1/2 cubed. In order to understand the graphs that we start this course off with, we want to understand all these pictures, and we want to think in terms of all these pictures instead of thinking in terms of what we get when we punch buttons on a calculator, which really doesn't reinforce our understanding of anything. It's just a result we get from the calculator, and there's no activity involved in it. Now, there might be plenty of mental activity involved in figuring out what buttons to punch, but these geometric images are, I think, a key that's missing in a lot of what we hope to understand about mathematics. Now we're going to see where this goes and talk about some functions. Okay, now we want to talk about the values of function or the expression x squared, the expression 2 to the x. Okay, the values of x squared are easy to calculate. If x is 0, 0 times 0 is 0. If x is 1, 1 times 1 is 1. If x is 2, 2 times 2 is 4, and so forth. But we want to construct it. Okay, we want to use a constructive argument here. So 0 squared, of course, that means you multiply 0 by 0. If you got nothing, it doesn't matter how many times you multiply it by itself, you still end up with nothing. So we say that 0 squared is 0. 1 squared, well, 1 times 1 means you got 1, 1. And that's just 1. Now 2 squared, well, let's see. We got to have 2. So we've got 0 and 1 on our axis here. Okay, so we're going to have to locate 2. Now we've already done this. I'm going to do it kind of quickly. Okay, well, there's 2. So right there represents 2, and we need 2 of them. So that gets us 4. 2 squared is 4. 3 squared, well, we've got to get 3. So we have 2 here, and 3 is going to be about here. And now we've got to do three of these. Okay, 3 squared means 3 3s. So here's 3. Here's another 3, which gets us 6. And another one, which gets us 9. So 3 squared is 9. We could even go as far as 4 squared and get it on the board. It'd be 4 4s, it'd be out about here. And I'm going to even go to the extent of sketching a little curve. Through these points, you get kind of a smooth curve. Every time the numbers get further apart, right? So the curve has to kind of go like this. If we wanted to get out to 16 out here, that might be about here. You know, it still have to never be straight. Okay. Okay, well, that's pretty easy to see. We've already seen it. What about values of 2 to the x, where x is 0, 1, 2, 3, and 4, and so forth? Okay, well, 2 to the 0, you should know what 2 to the 0 is, that the majority of pre-calculus students get it wrong. So I'm just going to put a question mark there, because we don't want to have to deal with that just now. We'll see in a minute what we might want to do. Okay, 2 to the first power. Well, that just means we have a single 2. So that's going to be easy enough. That's just 2. Okay, 2 to the second power. Well, it's the same picture we had up here. Here's 2. And we do another 2. And we get 4. Two to the third power, what's that mean? Again, we kind of did it, but let's just do it again. We've got 2 here. So we get a couple of those. And that gives us 4. But then we need a couple of these. And that gets us all the way out to 8. And we could do 2 to the 4th. could be this much. See how much that's a little over handspan. Yeah, it's going to come out almost to the edge of the board here. I'm not going to do all the brackets and everything, but we'd have 2. And 2 times 2 then is 4. And 2 times 4 is 4 and 4. That's going to give us 8. And then we get 16. 8 and 8 gives us 16. And we see how these positions on the number line relative to 0 always double. These are always doubling. So if we wanted to draw a curve, might look something like this. Okay, now to address the idea of 2 to the 0, how do we extend the curve? The pattern of the curve, if we look at it this way, it's kind of getting steeper and steeper. If the curve follows a reasonable pattern, it's not going to suddenly change its concavity and come over here, 0. It's going to keep getting steeper and steeper. It's going to do something like this. From the pattern, it's more reasonable that this curve should go through the value 1 than the value 0. Okay, and it turns out that 2 to the 0 is 1. Not just because it makes more sense in terms of this, but because the algebra of it makes more sense. You have more consistency with the laws of exponents, which are one of the first things that we need to learn to do. Okay, so right there we have 2 patterns, a pattern for x squared and a pattern for 2 to the x.